Alright, good day guys. How are you all doing? We're talking about the basic aspect of linear algebra, and there are some certain things you need to understand about linear algebra is that the main aspect of linear algebra is based on vector and linear combination with a bunch of matrix expression. But literally, the main aspect of that vector operation is two categories. That is the addition of the vector and the scalar multiplication. And addition just literally means adding some certain vectors together. Why scalar? Scalar means using a particular normal constant number, just like you saying 2 times a certain particular vector. So we can actually adjoin the certain number by saying, let's say the constant is c. So c times a certain vector or d times a particular other certain vector. So when you combine the addition and the scalar multiplication of that particular vector, that is what we call a linear combination. The addition and the scalar multiplication of that particular vector. So they have to understand something is that we all know that we have what we call x, y, z as it, and even more than dimensions like that. So literally, if a particular vector like the vector v lies on a particular certain plane, that's it being on a particular one plane. Now, if the vector w now does not lie on that certain same plane, that means on the vector w is also on a particular different plane. In that point, since it is actually two vector, we can say that that kind of combination is possessed by what we call a two-dimensional plane. Just like you're saying your normal what do they call it? Your normal x and your y axis vector v. Your normal y and your x axis vector v and vector w. So that is one thing we need to understand first. And the second thing is that we have more than two-dimension plane. Just like we all know, we have three dimension, your s, y, and z, and much more things like that. Is that what we'll be actually explaining to ourselves with respect to is two-dimensional vector, and we'll move into some other certain things. Now, vector are always written in linear algebra in column, not in row. So like this, we have vector, and this are like the value, vector 1, vector 2. So the first component is based on the x-axis, while the second component is based on the what? The y-axis. The second thing we have to know is that, like I've told you, that it is not always written in row, it's always in column. But at times, so as not to eat up space, if the vector are too much, we can express this vector, that's the column vector, like this, not like this. If you put a particular rectangular braces like this, we are referring to row. Okay, so under normal vector addition and subtraction, when you have a particular vector and let's say a particular certain vector w, we add their what? We add them together based on respect to their components. That is vector w, the x component plus the s component, the y component plus the y component. That is how we add. This is like a normal matrix little addition. And also when it comes to the subtraction, the same way. The s component minus the s component, while the y component minus the y component. So let's discuss one or two things much more extensively. Alright, so when we talk about scalar multiplication of a certain vector, it's the process of using a particular numerical value to multiply a certain vector. So let's assume the vector, we have vector v equals to v1, then v2, and that's the s component and the y component. So literally when 2 multiplies the vector, it affects the s component, and with respect to also the y component. So literally if minus times v, this minus also like you saying minus 1 times the vector, and in that moment it also affects the s component and the y component. So components of the multiplication of the scalar are going to be cv1 and cv2. And also you should know that when you have a negative vector and a positive vector, just like you moving in a particular positive and negative direction, when they are being combined together, what does it give us? It gives us what we call a zero vector. Now a zero vector is not just ordinary vector that is just a normal value of 0. No, the value that is assigned to zero vector is with numerical value of 0, and also it has a component of 0. So under linear combination that we're talking about, when you add the particular linear combination together, it is with respect to vector v and vector w. Now like I told you, you can have more than, you can even have and vector, you can say you have vector z. You get what I'm saying? So there are many more. If you have vector z, that means since you have cv dw, you should know that you just have plus what? You can say, let's say you can have kz. You get what I'm saying? So much more combinations like that, the more the vector are being surplus. So the sum of these two is the combination of this particular vector. Now you have to note that whenever you see a space, what does the space mean? Literally, when you are drawing your dimension, just like I explained at that time, that whenever you see a space of a vector, the zero vector is usually included in every aspect. That means that this is your y-axis, this is your x-axis. The point at which you are going to start on has to be with respect to what? 0. That is a 0x axis and a 0y axis. You get what I'm saying? So literally 0 vector is usually what's included in what every direction of the combination of any given vector. So there are some four specials of linear combination that we need to understand, and I will tell you why literally they are being combined. Do you know that even V and W, if we are to include one V and one W, this is already a normal combination of because we can easily say that from here C is 1 and D is what? 1. That was why we have ordinarily what? A vector V and vector W. Hope you get my logic. You can have more than that. Now from there, when we talk about the four special linear combination, the first one is sum of vector. That's when it's being combined. You know this C now, we can see that C is equals to D and is equals to 1. That means that what? This is just like you saying CV plus what? DW. Also known as the sum of vector. Difference also, just like you saying CV minus CW. And the zero vector, like I told you, that zero vector is a vector that has zero components and what? A zero numerical value. So the value is related to the vector, the value is related to the what? To the vector. And also again, like I have said, if you have a particular certain vector, if I say vector of CV, you know CV is actually a normal vector, a one vector. So I'm going with respect to its own plane. Any other plane, I'm less concerned about it. So literally, since I'm considering a two-dimensional plane, if I'm talking about a vector CV in the direction of what? Vector V. Literally, I will only be having vector CV plus what? A no vector. Again, I'm saying that's like what? Zero vector of what? Vector W, because the only one I'm considering is the direction of vector V. So literally, under addition of vector, like I was saying the other time, if you have vector V and vector W, when you want to add them together, just like you're saying x component plus x component, y component plus what? Y component. 1 plus 2, 3, 2 plus what? 3. You have 5. So the same thing goes to the subtraction. And like I said that what? Literally, a vector is not being written like this. You can't have a vector V1, V2. This is the normal column way to write a vector. So, and at times we can write it like this, V1, V2. Are you with me? That is if the space is, we can have more than two-dimensional vector, like I said. You can have 3, you can have 4. So if the space is a little bit too much, the space is a little bit small, we can write it normal like this, but not like this. V1, V2. This is considering row. So you write the vector of linear algebra with respect to a column aspect. So this is like a basic explanation of one or two things that we need to know under linear combination. It's like a normal primary aspect of it. What we need to know under linear combination and the vector itself. So move on to some other, step-by-step aspects of it. My name is CryptoQuanta. Please try to subscribe to our channel in order to get updated whenever we post certain particular videos. Thank you.